Okay, this is your practice test for Chapter 9 on Inequalities in the MathLinks 9 program. Today's date is February 25th. The first 5 questions are true and false, and it says 7 is greater than x. Reads all numbers less than 7. And the trick to this is, if you look at this inequality right here, and I'll just make it a little bit bigger. What you were told to do is, if you have a variable, read the variable towards the number. So if I read x, I could also read it as all numbers. And then when I read all numbers, this inequality symbol is not consuming or eating, as we normally think of it as being a Pac-Man, eating what I said. So when I said all numbers, the inequality sign is not eating all numbers, so therefore I read it as all numbers less than 7. And all numbers less than 7 is what it says, so therefore that inequality is true. That's exactly what it says. Question 2 says, in the equality of all numbers less than or equal to -1, 0 is a value that x can be. And the answer for this is, of course, false, because 0 is less than negative. If I substitute 0 for there and say, is 0 less than or equal to -1, the answer is no, it's not. It's greater than -1. So therefore, that's why it's false. Your next question said, if -2x is greater than 4, then, it should be then, not the, then x is greater than -2. Is this true or false? So the first thing I can do here, and there's different ways you can do this, but if I take this and isolate the variable by dividing both sides by -2, the trick is when you multiply or divide both sides by a negative value in an inequality, as you isolate the variable, you must flip your sign. So what this is, any value less than -2 would be true for this. And since this says all values greater than -2, and this says all values less than -2, it must be false. Another way you could have done that is taken any value that was greater than -2. For example, 0 is greater than -2. And if I substitute 0 into that inequality, 0 is not greater than 4, so therefore it's not true. So even though 0 is a value that is greater than -2, it will not work in this inequality. Question number 4 says all values less than -1.5 would be graphed as the following. And since this is a closed boundary point, it is all values that are less than or equal to -1.5, and all values less than -1.5. Because this is a closed boundary point includes the value -1.5, and since it says all values less than and not including equal to, this symbol is not a part of it, we must say false. If it had said all values less than or equal to -1.5 would be graphed as this, then it would have been true because of that closed boundary point. But because that closed boundary point was there, you must include or equal to. Question 5 says this line includes all the values less than 2 but more than -2. All the values less than 2. So all of the values less than 2 is this way here, and all the values more than -2 is this way. But the only problem is, because that's a closed boundary point, just like the last question, it's all the values less than or equal to 2, but no more than -2. So the answer for this one is false, and all because that's a closed boundary point right there. Question 6 has 3 parts. It says write the appropriate inequality and graph it on an underline. So it says save up to 25%. Now, I said before, this is kind of subjective because up to 25%, are we saying that 25% is included or isn't included? And I guess when you read that, it does seem like it is included. So when you put 25% here, you could also put it as a decimal, 0.25. You can do either one of them. You would probably have 26% here, or 0.26, and 24% here, or you might have 0.24. Either one's fine. And save up to 25%. If I was to write it as an inequality, all values that are less than or equal to 25% is what I really want to say. Any value that's less than or equal to 25% is saving up to 25%. So I will probably use a closed boundary point and any value this way towards 0%. I guess you can have negative percents too, so it is an infinite value, would be true for your number line. So you'd get 1 point on your test for this, and you would get 1 point on your test for having this number line with the appropriate values labeled. The second part to that question, I should say B, not A. All children under the age of 9 can swim. So under the age of 9, if I put 9 here and 8 here and 7 here, or 10 here, excuse me, all the under the age of 9, that means you cannot be 9 years old to swim in this particular pool, whether it's a kiddie pool or whatever. So we're going to use an open boundary point for this, and any age below that, I guess to 0, but we don't have 0 listed there. And we would then say any age, or instead of using X, we could use A, any age less than age of 9 can swim. So you get 1 point for your inequality and 1 point for your graph. And finally, your last question, everyone 19 years or older may smoke. So if I put 19 here and 20 years old here and 18 years old, anyone that's 19 years old, closed boundary point, or older can smoke. So therefore, anyone that has an age of greater than or equal to 19 is able to smoke. You shouldn't, because smoking is bad for your health, but anyone that's 19 years or old or older in the eyes of the courts can. Your next question, your next question says interpret the number line as both an inequality and as a sentence. So the first one has an open boundary point, and it appears to be at 1.5. So any value that is greater than 1.5 would be expressed in that number line. And remember, we're not using a closed boundary point. If it was closed, which it's not, but if it was, we would include that symbol. But because it's not closed, it's an open boundary. And therefore, any value that's greater than 1.5 would fit on that number line. As a sentence, any value greater than 1.5. And our second question is any value less than or equal to 4, and any value less than or equal to 4 would be how we would express it as inequality. And finally, the last one, any value greater than negative 0. Actually, that's 7.5, isn't it? I can't even read my own graph here. Should make that a little bit bigger. Yeah, there it is. Negative 0.75, or any value greater than open boundary point, so not equal to negative 0.75. Your next question says solve each inequality and graph the solution. So the first one, negative 5 plus x is less than 10. Just like if you were doing an equality, you would get rid of the constant first to find any value that is less than 15 would be values that we could substitute for x to make it true. And if I think about, just to double check my answer, any value that's less than 15, if I say, well, x can be, for example, 10, because 10 is less than 15. So if I was to take my inequality, I'll just erase this for a second, and substitute the x, instead of using x, I use the number 10. Negative 5 plus 10 is 5, and 5 is less than 10, so 10 is a value that if I substituted for x would keep it less than 10. So that's true. In my next question, it says 2x minus 5 is less than or equal to 1. So just like if I was isolating, I'm going to add 5 to get rid of the constant. I have 2x is less than or equal to 6. Divide both sides by 2. And any value that is less than or equal to 3 is a value that I could substitute into this inequality and make it true. Oh, by the way, I forgot this one. Oopsie daisy. I'll go back and do that in a second. So any value less than or equal to 3, so I'm going to put 3 here. I'm going to put 2 here. I'm going to put 4 here. Any value that is less than or equal to, so closed boundary point, less than or equal to goes there. And if I go back to my first one, the first A, any value less than 15, I'm going to put a 15 here. I'm going to put a 16 here. I'm going to put a 14 here. Open boundary point less than, looks like that. And your last question gives you a negative half of x. Minus 1 is less than 1. So we're going to add 1 to both sides. I'm going to get rid of the constant. A negative half of x is less than 2. Multiply both sides by negative 2. And because I multiplied by negative 2, I have to flip my inequality sign. And any value that is greater than -4 makes this inequality true. Open boundary point because it does not include -4. And I'm going to say any value that's greater than -4, which would be this way on my number line. My next question says solve the inequalities again and graph the solution. So we're just a little bit more complicated with these inequalities because we have things with distributed property, we have things with variables on both sides, and we have inequalities that contain fractions. So in our first one, -2 groups of 2x minus 1 is greater than or equal to -4. Two ways you can solve it. Obviously, you could expand using distributive property first, which would give you -4x plus 2 is greater than or equal to -4. Or alternatively, we learned that if you have -2 groups of something and you divide by -2, you will have one group of it. Now, if you did this way, the problem is because you're multiplying or dividing both sides by a negative, you do have to flip your inequality sign. So you'll end up with this. So if you had -2 groups of 2x minus 1 equals -4, then one group of 2x minus 1 will be less than or equal to 2. And then you'll just add 1 to both sides. You'll have 2x is less than or equal to 3. Divide both sides by 2. And any value that is less than or equal to 1.5 will be true. So if you take your number line and put 1.5 here and 2 here and 1 there, or any you can do different ones if you wanted. Any value that is less than or equal to means a closed boundary point, and less than or equal to 1.5 would mean our number line goes that way. If we take our next inequality, we have 5x minus 3 is less than 3x minus 10. So just like when we did equalities in chapter 8, if you have variables on both sides, it's easiest to get rid of it from one side that has the least amount by creating an algebraic zero pair. So 3x and -3x would make an algebraic zero pair, leaving with -10 on that side. And a positive 5x and a -3x would make a 2x. And 2x minus 1 is less than -10. Now we have a simple inequality. Add 1 to both sides, you get 2x is less than -9. Divide both sides by 2, and x will be less than -4.5. So going over to my number line, I'm going to put -4.5 here, -5 on that side, and -4 on this side. And since it is not equal to, I'm going to use an open boundary point, and any value that is less than -4.5 would be that way on my number line. And our last question, question 9, gives you the fractions. And again, what we learned from our experience with equations in chapter 8 with fractions, you can do one of two things. We could multiply both sides by a common multiple of the denominator. So if I think about 5, 3, and 4, and I was to write all their multiples, those would be the multiples. Oh my God, that took me a long time. I had to press pause to do it. But if you look at the multiples and you look at which ones they share, the first multiple all three numbers share is 60. So what I technically could do is multiply this side by 60 and multiply this side by 60, and I would create an equation that still maintains its balance or maintains its inequality, but it's 60 times larger on both sides. But fortunately for us, that's not the easiest way. And the easiest way is to simply add 2/3 to both sides. And when we do that, we're left with just a fifth of x is less than or equal to. But when we take this next one here, and I think to myself, what is this going to be? Then I'm going to change this to, 1 3/4 is going to be 7/4 plus 2/3. Adding fractions requires common denominators. I'm going to find the common denominator, and 21/12 and 8/12 make 29/12, which is going to be 2 and 5/12 as a mixed fraction. So I'm going to keep it as 29/12 because I know I'm not done with it, so I might as well keep it improper. Because in my next step, I'm going to be multiplying it by 5. And rather do this question, which is a little bit more complicated. I'm going to keep it as a mixed or improper fraction. I'm going to write it as 5 over 1. 5 times 20 is 100. 5 times 9 is 45. So it's 145 over 12, which as a mixed fraction is 12, which is 144, and 1/12 left over. So any value that is less than or equal to 12 and 1/12. So I'm going to put 12 and 1/12 here. I'm going to put 12 and 2/12 here, or if you wanted to express it in lowest terms, you can go 12 and 1/6, which is 2/12. And you would just do 12 over here. So 12, 12 and 1/12, 12 and 1/6. going up by twelfths. Any number that is less than or equal to would be a closed boundary point, and less than or equal would go that way. For question 10 through 12, it says define the variable, write the inequality, solve it, and then write a sentence to show your answer. So there's really 4 parts to doing each of these. So the first question in 10 says Toby is saving up to afford to buy a ring for his girlfriend, and he has saved up $142 so far. If the ring costs, $1,000 and he makes $12.80 an hour at his job, what is the minimum number of hours he must work in order to have enough money? So his money saved. So the first thing I'm going to do is, before I even define the variable, his money, that's not how you spell money. His money saved has to be greater than or equal to, in total, $1,000 if he's going to be able to afford the ring. So his money saved has to be greater than or equal to $1,000 in order for him to be able to afford it. So if we think about this, if X equals the number of hours he's going to have to work, then if I take that number of hours and multiply it by $12.80, so $12.80 multiplied by the number of hours he works, think of it as a coefficient, plus the current money he has saved, which is a constant in this equation because he already has $142.50, has to be greater than or equal to $1,000. And what I've done here is I've now I've written my inequality, okay? The next part says to solve it. So I'm going to subtract 142.50 from both sides. That's going to leave me with $12.80 multiplied by the number of hours. Has to be greater than or equal to whatever 1,000. Take away 142.50 is, and that is $857.50. Oh, I forgot the number already. Shoot. Short-term memory. 1,000. Take away 142.50. 857.50. And this will be still 1280x because all I've gotten rid of is the constant. Now what we're going to do is divide both sides by the coefficient. And when I take that number, $857.50, and divide it by the coefficient of 12.80, if you want to put it, it works out to be 66.9921875. So therefore, 66.99, so X has to be greater than or equal to 66.99. So he has to work. Therefore, since X represents the number of hours, he has to work at least 66.99 hours. So therefore, he must work 66.99 hours or more to afford the ring. Now, obviously, since you can't work 0.99 hours, you're probably going to put he must work greater than or equal to 67 hours, right? Because you'd round that to the nearest decimal. But just in case, maybe they do give part hours at whatever job he has. So it could be possible that 66.99 is an hour he can work. Our next question says, Izzo is buying her friend's pizza at Michael's. If each slice costs $4.25 and she has $55.25, what is the maximum number of friends she can treat? So the first thing I'm going to say is X is going to equal the number of friends she can buy. Number of friends she can buy for. How do I know that's going to be my variable? Well, it's because it's what the question is. It says, what is the maximum number of friends? So usually the question is going to be your variable, usually. So if I think about it, it's $4.25 per friend. So let me just put this in. So the cost of pizza in word form must be less than or equal to $55.25 because that's all she has for money. So if you think about, well, what's the pizza going to cost her? Well, it's going to cost her $4.25 multiplied by X, which we're going to make the number of friends she buys for. Oh, I already did that, sorry. Brain fart. So 4.25 multiplied by X is going to be less than or equal to the amount of money she has, which is 55.25. Here, this is a little bit easier than the last question because all we have to do is divide by 4.25. And when I take the calculator and I say, what is 55.25 divided by the cost of a slice, I find that X must be less than or equal to 13. So therefore, she can buy pizza for up to and including 13 friends, because she can have less than or equal to 13 friends and still be able to afford the pizza with her 55.25. And our last story questions, story question? Story problem question. It says Lucy is a singer. She would like to make a CD and she has two companies to choose from. Company A will charge a flat fee of $26.80 per CD, which is a lot for a CD printing, while Company B will only charge you $6.70 per CD, but you must pay a printing recording fee that works out with tax and whatever to $2,412. To be honest, it worked out to that because when I made the question up, it allowed the number of CDs to be a whole number rather than a decimal. How many CDs would you need to sell to make A the cheaper option? So before I do anything, I want Company A to be less than Company B. That's my goal, is to make going with Company A the cheaper option. So A has to be less than B. So if I think about what this is going to be, X is going to represent the number of CDs they sell. Okay? At Company A, it says we'll charge just $26.80 per CD. So $26.80 multiplied by the number of CDs will be $26.80 multiplied by X, or a coefficient, will be less than Company B, which is a much smaller coefficient, 6.70X. And you don't need the zero in either one of those coefficients, but they're there. Plus that fee of $24.12. So what we now have is we have an inequality that has variables on both sides. And like the previous question, if I want to get rid of it on one side, I'm going to create that algebraic zero pair by subtracting that amount of X from both sides. That will leave me with that fee of $24.12 will be greater than $20.10 multiplied by the number of CDs they sell. Divide both sides by the coefficient of 2010. And I will have, if I take my thing, $24 or $2,412 divided by 2010 equals 120. So therefore, X must be less than 120. So if she sells less than 120 CDs, option A is better. Which makes sense, because let's face it, if she sold a million CDs printed at $6.70 each, that $2,412 fee is recouped much faster if you're going to sell that many. But if you're only going to sell less than 120 CDs, option A is better. Now, if you sell exactly 120 CDs, option B will be better. But if you sell less than 120 CDs, then option A is the better deal.